Okay, so this is section 2.7, Foundations of Math 10, number 12 from your homework assignment. Okay. So this looks really familiar, seeing as we are in Regina, Saskatchewan. This is our legislative building that I can actually see from my window here. I think I can see the tip of it somewhere. Pretty close, but anyways, you can see it from here. And it says this, Janelle stood due south of the tower, which we are due south of the tower, actually. But we're a little bit further than 40 meters. So she is due south from the tower 40 meters from a point directly beneath the dome. Okay, so let's let me read through the question before I do the diagram. She measured the angle of elevation to the top of the dome at 53 degrees. Troy stood due east of the tower and measured the angle of elevation of the top of the dome to 61. Okay, so we've got two different people looking at the top of the dome of the ledge. Okay, and they are different distances from the ledge. How do I know that? Because the angle of elevations are different. Remember the tree example? The person stood halfway between two trees, and you had to look up higher for one, lower for the other, so the one you had to look higher up to was taller, right? Okay, so this is how you want to draw this, okay? Due south, due east, okay? Bit tricky. Since we're going to draw this at the same time, what you want to do, and this is why I hesitated to read through the question, because this is going to be the dome, okay? So here's the ledge here, okay? There's the ledge. Not a very good drawing, but that's the ledge. And this is the point that's directly underneath the dome, okay? And it says that Janelle stood 40 meters, and she was due south. Okay, so what we're going to do, guys, is we're going to make this due south. I know it's on an angle, but watch this. This is going to be 90 degrees, okay? So you want to draw this on an angle because there's two people looking at the dome. So she is 40 meters away. So this is going to be 40 from a point directly. So here's Janelle over here, Jay. The angle of elevation that she measured to the top was 53. So from here, okay, draw this line. And again, you'll hopefully draw a better line than me because this is tricky on this little tablet here. Oh, it's not too bad. So that's 53 degrees. Everyone see that? So this is south, this way. Now the reason why I didn't draw it south, like straight up and down, is because you wouldn't be able to see the triangle, right? So I drew it on an angle so you could kind of see the triangle. Now the other guy, Troy, stood due east. Now if this is south, this would be east over here, and it would be at a 90-degree angle. Be a 90-degree angle to the line that Janelle makes. So this is 90 degrees as well, south and east. Okay, everyone seeing that? So there's a specific example in your text, actually, that does a question just like this. So you would be able to see that, and it's example number 3, page 116. Okay, just shout that out here. So this is sort of, I'm modeling this after that example a bit. And so the angle of elevation for him is 61. Okay, 61. Now, if this angle right here is 61, he has to look up higher to see the same point. So guess what? It's going to make sense that he's a little bit, what? Closer. Yeah, very good. If you're closer to a tall object, you have to look up higher. Okay, well, we're getting some information here. That's great. So it says, the first question is, how high is the top of the dome? Second question says, how far is Troy from the point? So we're looking for H. Then we're looking for, I'll say little, well, this is where Troy is, so we'll say this is little t. It's not opposite, but Troy's distance. And then how far apart are Janelle and Troy? The last one is this one. What is the length of JT? Okay, so this is JT here. That's for C. So you asked specifically about C. You have to find the other parts first, and then you see you have actually a right triangle here. You can, okay. All right, so finding H. How do I find H given what I'm given? You can do this now. Anybody have any ideas? Want to shout it out here? Yes. Okay, so you're spotting this right triangle here with the 53, and you've got the adjacent side is given, and you can solve for the opposite side. So TOA, tan. Very good. So let's just show that up here. I'm going to go tan of 53, like you said, equals opposite. That's H over 40, right? So H equals 40 tan 53. H equals. And remember, I am modeling for you exactly how you do these questions. So write out your tan ratio. Put it down. Isolate the variable. Put that row down. Do not skip. Okay, do not skip steps here, because again you'll fool yourself. What do I multiply 40 times tan 53? Do I do 40 divided by tan 53? Do I do tan 53 divided by 40? What do I do? This is how you know. Set it up. Take a look at where your H is, and look at how you need to manipulate here. 40 multiplies. Okay, so what is that? 40 times tan of 53 is times tan 53. Make sure you're in degrees, and you should get 53.08. Does that sound right? Awesome. 53.08. Now we'll leave a bunch of our decimal places, I guess. We'll leave that on the calculator, so I might be able to use that. But that's what H is. So A, 53.08 to the nearest whatever, it doesn't matter. What is that? Meters? Meters. 53 meters tall. Wow, that's pretty tall. Okay. I highly doubt that dome is actually 53 meters tall. But anyways, it's okay. It's okay. It could. I doubt it. All right. What's next? Okay. So that's A. Good. B. How far is Troy from the point? Oh, wow. We have H now. So guess what? I can solve for this part. So here's my H, which is 53, and here is Troy over here. I'm just redrawing this little triangle, two-dimensionally now, and this is 61. Look at that. So I can solve for this little t right here. See? And I'm looking, so I have opposite and I have adjacent. So what trig function is that? Tan. Yeah, very good. We're going to do tan again. Okay, so let's do it down here. So tan 61 equals opposite 53 over our unknown side. Good. And multiply this up there and divide both sides by this. So t and tan of 61 trade spots. So that's why t is 53 over tan 61. Right? See that? 63 divided by tan of 60. Whoa. 53. Whoa, hold the bus here. Tan of 61. Okay. Does that look good? Please correct me if I'm doing anything wrong here, because I'm not really checking my work so much here. You guys are my 30 checkers, right? So 29.38, 29.4. So T, 29.4. You guys get that for an answer? So he's 29 meters away. See, he's closer. We were right. He's closer than 40. Awesome. So we've got A, we've got B. Now, C, this is great. C is really easy now because I have a right triangle on the ground here. See that? It's a right triangle. And I know this is 40, and I know this now is 29.4. So I can use what? Do I need to know this angle or this angle? I don't really need to know that, do I? Pythagoras, right on. Okay, very, very good. So Pythagoras, let me just back that up a bit here now. Oops, too far. So if I redraw this triangle here, so I've got 40, I've got a right triangle. This was blah, blah. Shoot, I just erased it. What was it? What was T? 29.4. Okay, and then I want to find this side right here. No problem. That's Pythagoras. So that's be JT, right? So JT squared equals 40 squared plus 29.4 squared. That's the Pythagorean theorem. The sum of the squares of the legs equals the square of the hypotenuse. All right, and then I'll just do that down here. Okay, so 40 squared is 1600, of course. 29.4 squared, 864.36. And again, notice, I'm just doing this a piece at a time. Okay? It'll take an extra 7.5 seconds out of your life to do this. If you do it all on your calculator all at once, square root 40 squared plus 29.4 squared, it might work. It might work. But if you hit one wrong button on that long calculation, then it won't work and you won't know. So I like to chunk it down a little bit, take it a piece at a time. See, I almost forgot my square there. I'm talking too much. Okay? So add this up. What is it? This plus the 1600 that I found before is 2464.36. Okay? This is maybe a bit of a bonus. Would I require you to do this step? Maybe not. You wouldn't need to do all of them, but just make sure you don't make a mistake. So 2464 54.36. If you do this on a test, there's absolutely no way that there's no way that I would miss the fact that you know exactly what you're doing, okay? If you skip a bunch of steps, it's like, okay, did you guess? And then if you get it wrong, how many part marks can I give you? I don't know. I don't know how much you know. Okay, so square root of the answer. And if you get to know how to use your calculator like this, you can save yourself a lot of time. So square root of the answer is 49.64. Now that looks like is what this should be. Is that the right answer? Okay, so for C, 49.6 meters apart. That's better. Okay, so that's number 12. It's a bit of a long question, but the key is if you're drawing sort of two directions at once, you have to kind of draw the triangles three-dimensionally a little bit, okay? And then you can draw it all at once.